Real estate rental property analysis project. This project used historical rental data in Houston, Texas to estimate other properties' rent amount and how long it takes to rent out. So expenses and rent data then is used to calculate net income. Then net income is used to calculate cash on cash return. So there are three sets of data that we input. Set number 1, rental data, which is downloaded from a website. Set number 2, sales data, which is also downloaded from a website. However, set number 3, interest rate and mortgage percentage, that is user input data because everybody's interest rate is different, so user needs to put their own interest rate in there. Then we're going to slightly process the data. So for example, you use full address to generate longitude and latitude, and use interest rate, loan amount, terms of the loan to generate monthly mortgage payment, and then everything else is directly from the data. Then we use this data to find out rent and cumulative days on market, which means how long it took to rent. Then we're going to calculate net profits and cash on cash return. After that, we can use all of the data we have to sort and filter to select the properties we like. A few highlights. API is used for geocoding, which means convert address to longitude and latitude. Database is used to store and process data. And programming languages, Python and SQL. So I want to talk about the algorithm, which is, so the red spot here is property for sale on the market, and everything else are historical rented out properties. So I know how much they're rented out for, how long it took, and I want to draw a small square first, and then draw a circle. This circle is a 1 mile radius circle, and I'm only interested in the properties that's inside this circle, which are the yellow spots, and I'm going to use these yellow spots to estimate how much the red spot is going to be rented out. And the reason I want to draw a square first is because the formula for drawing square is a lot easier than the formula for drawing a circle. So in order to draw a square, I only need to define the upper and lower range of longitude and latitude. However, to draw a circle, it's more complicated because Earth is a sphere. So the formula for drawing a square on Earth is a lot more complicated because I need to calculate the distance between any 2 points and the target property. And you calculate the distance between these two to see which one is greater than 1 and filter out all of those, which is too much calculation. So in order to do that, I have a subquery, and this does exactly what the picture shows. As you can see, these two lines calculate the distance between 2 points, and then the where clause here will filter out everything outside of the square, and then this where clause is going to filter out everything outside of the circle. And because there are thousands of properties on sale on the market right now, so we're not only drawing square for one property, we're drawing squares for thousands of them. For each one of the property, we're going to draw a square for them, and does the same thing. Select all the properties in the square. So after that, we need to use the properties that we selected, which are the yellow spots, to do some calculation. And here I use aggregate functions to calculate the average rent for the yellow property, and so on. After that, of course, since we use aggregate functions, we need to group them by primary key. And here is the result after I selected, I filter out based on what I like. And this is 3 properties out of about 2,000 properties I selected. And now we can talk about how to optimize it because it takes so long to run the program. So slicing the map into small squares ahead of time instead of filtering out all the data, I can select data in squares nearby and filter them. So here's how it works. Originally, it's going to draw a square for every single one of them and filter out all the blue ones. And there are about 20,000 of the blue ones. That's why it takes time. So now, instead of filtering out all the blue ones, I can only select the square right here where the red spot is and all the squares around it. So I will be able to save a lot of time, and I don't have to try to look out for every single blue square.